we always think of the future as something way off in the distance, flying cars, all that sci-fi stuff. Well, 2025 is shaping up to be different. It feels like the year where science fiction stops being fiction and starts becoming a real, tangible part of our lives. I mean, what if those groundbreaking innovations we've all been waiting for are already here, popping up out of the world's top universities? We're talking about real solutions to some of humanity's biggest challenges, and they're happening right now. So today we're going to look at the research that's literally bringing the future to life. So first up, let's dive into how science is totally changing our relationship with our own bodies. We're talking about everything from overcoming huge physical limitations to correcting the very source code of disease itself. For, ever, prosthetics have been these kind of clumsy external tools. But that is all changing. We're moving from just detached devices to limbs that are truly integrated with the body. Get this, MIT's Her Lab has developed something called the EOPRA Bionic limb. It's a robotic leg that's surgically fused right to a patient's bone and, this is the incredible part, to their nervous system. This isn't just a replacement anymore, it's a full-on restoration. Just stop and think about that for a second. The ability to actually feel the ground under your feet. To have a limb that just responds to your thoughts, exactly like a biological one. It's a complete game changer, giving people back not just their movement, but the actual sensation of being whole. Okay, so let's go from the macro, big picture stuff down to the micro. For generations, we've fought against genetic diseases, things like sickle cell anemia or progeria, mostly by just treating the symptoms. But the root cause, that single tiny error in our DNA, has always been untouchable. Well, until now. This is a breakthrough from Harvard University, and it's called prime editing. Think of it like a molecular word processor for our genes. It can literally search for a specific typo in our DNA and then just correct it. And it does all this without making a dangerous cut across the whole double helix. This is huge. It moves medicine from just managing a disease to potentially delivering a permanent cure. Now, let's look at a challenge that affects millions of people every single day. For people with Parkinson's disease, one of the most terrifying symptoms is what's known as the freeze. It's the sudden, involuntary moment where the body just loses the ability to take a step. And that, of course, leads to a huge risk of dangerous falls and a loss of independence. And the solution that's come out of Harvard is it's both brilliant and so elegant. It's not some big, bulky machine. It's a soft, wearable exosuit that feels like clothing. It's smart enough to sense when a person's muscles are about to freeze up, and then it gives this gentle mechanical burst at the hip to help them complete their step. It gives mobility and, maybe even more importantly, confidence back to millions. Okay, so from healing the human body, let's zoom out and shift our focus to healing the planet. The conversation in science is moving beyond just slowing down the damage. Now it's about how we can actively repair our world. So here's a huge question in climate science. Can we really, truly rely on the ocean to help absorb all our excess carbon? It's got this immense potential, right? But the big hurdle has always been verification. How do we know for sure that it's actually working and that it's safe and effective? Well, scientists at Yale have come up with the answer. It's a system they call the Stack. Basically, it's an AI-powered forecasting tool, and it predicts with incredible accuracy just how much carbon the ocean can safely absorb and store away. This gives us the hard data we need to validate marine carbon removal, turning what was a theoretical idea into a real, verifiable climate solution. Let's talk energy. We've all seen those huge, sprawling solar farms, right? But what if we could do it differently? Researchers at Oxford have developed something revolutionary. A flexible solar coating made from a crystal-like material called perovskite. You can basically paint or wrap this stuff onto almost any surface, and it matches the 27+% efficiency of traditional rigid panels. I mean, just imagine buildings, cars, even our backpacks, all generating their own power. And now for a statistic that is it's truly shocking, and it completely reframes a massive problem. Researchers at Stanford used a new AI model and discovered that a staggering 80% of wildfire ignitions are caused by just 5% of our power lines. The problem isn't the entire grid, it's a tiny, super vulnerable piece of it. So what does this mean? Well, it gives utility companies a surgical berry map.
Instead of facing the impossible, insanely expensive task of rebuilding the entire grid, they can focus on burying just that critical 5%. It makes preventing catastrophic wildfires a practical, cost-effective strategy. All right, in our final section, we're going to look at how intelligent systems and smart materials are engineering a world that's safer, simpler, and way more accessible for all of us. You know, traditional body armor, it's heavy, it's rigid, it's super uncomfortable. But engineers at Caltech have completely reinvented it with something that sounds like it's straight out of a comic book. It's a soft, flexible, almost chainmail-like fabric that instantly becomes rigid the moment it's hit. It offers incredible protection for first responders and athletes without sacrificing any comfort or mobility. How about this for making creativity available to everyone? A new system from MIT lets you just say what you want to build. You know, make me a wooden chair. An AI then designs the whole thing, and a robotic arm assembles it for you. This completely removes the need for complex skills like CAD design or carpentry. Suddenly, anyone can be a maker. Now, this one is a truly profound shift in medicine. Historically, we've only been able to diagnose dementia after the devastating symptoms like memory loss have already started. But a new AI foundation model from Cambridge can analyze brain scans and spot the earliest signs of the disease years before a single symptom ever appears. This opens up this incredible window for intervention while the brain is still healthy. 150 miles per hour. That's how fast a race car went on a professional track, piloted entirely by an AI from Caltech. And it wasn't just about going fast. It actually handled the extreme, on-the-edge conditions of a race better than professional human drivers. So why should you care about a robot race car driver? Because that racetrack is the ultimate testing ground for the real world. Proving an AI can handle a car at its absolute physical limit means that our future autonomous vehicles like self-driving ambulances and cars will be so much more capable of handling unexpected emergencies on the road. You know, black ice, a sudden downpour, or another car swerving right in front of you. So, what's the big takeaway from all of this? It's pretty clear. These breakthroughs aren't just fascinating experiments happening in a lab somewhere. They represent a whole new arsenal of real, practical tools that we can actually use to solve our most pressing challenges, from our own personal health to the health of our entire planet. We are entering a new era of living science, where progress isn't some abstract idea for the future, but a concrete reality that we can see and touch right now. And that leaves us with a really powerful question. With tools this incredible now at our disposal, what monumental challenge should we decide to solve next?